to be, it's a technical presentation, and it's going to be on the safety laser scanners. And we're going to be talking about two different variants, the two newest variants of our family. We have a long family of laser scanners, but the two newest ones, and we'll talk about where you'd use them and why and what makes them so great. So the first subject we're going to be talking about is the MicroScan. And that falls into the product family. So back in 1994, we introduced the PLS. We were the inventors of the safety laser scanner. I actually worked on the PLSs way back when. They lasted forever. There's still some in production. These things are super robust. And then we jumped into the S3000s back in 2003. Those are still out there and still a viable product. So these products last a long time. Then we jumped to S300. As you can see, the scanners were getting smaller and smaller, and then they started adding more. Profinet was one of the first safe networks, jumped into that S3000, S300 family. And then in 2016, we finally came out with a brand new platform called the MicroScan3. So from 1994 to 2016, we are the leaders in this segment of safety, and we continue to innovate. So what's some of the key points about the MicroScan? Now the MicroScan in the new world is going to be the bigger of the two new variants that we're launching. They can be used in two basic applications: stationary applications, as we're showing on the left, and mobile applications on the right. So the difference is, in mobile applications, you have to have a lot more field sets. You have to have a lot more things going on because an automatic guided vehicle or an automatic guided cart is going straight, it's going slow, it's going fast, it's turning left, it's turning right. So you often have 50 to 100 different field sets. So we call that the scanner that would be used for mobile applications a Pro, just because you can get up to 128 field sets, and sometimes you need that many. And then the scanner that you would use in stationary applications is usually industrial applications, robot cells, safeguarding a paper machine, just about anything that's a stationary machine where you don't have the luxury of having maybe a light curtain, or you don't want to have physical guards around the equipment. So when we say core, we mean stationary, factory automation type applications in most cases. And when we say Pro, we mean mobile applications and many field sets, just to make that clear. Sometimes we think everybody knows what we're talking about, but that's the two variants that we have in all of the families. So what have we done over the last 20 years to make scanners better? So we invented the laser scanner. The PLS was a darn good machine. That thing ran forever. Like I said, there's still some people having them out there. You can't program them anymore, because the computers have advanced, but they still are running. They last a long time. These things have a mean time to failure of like 20 years. But we had to make some improvements. The big issues that people were having with scanners over the years, even with our last version of laser scanner, was PLS, S3000. Ambient light would be a major problem. If you open your bay windows or sunlight shined in, you had major problems. Flying sparks and parts and things like that gave us a lot of problems. Not a lot, but enough problems that we had to address it. Mutual interference was an issue. People didn't like the fact that you had to mount your scanners offset so that they wouldn't crosstalk. And if you've got 4 or 8 scanners in an area, which isn't unusual, you can have some crosstalk. And then the biggest thing was dirt and dust causing false trips. And false trips and shutting machines down is never a good thing. So we addressed these things in the new scanner using HDDM technology. We'll use that term. That term means high definition distance measurement. What we're doing is we're spinning the laser inside the laser scanner, sending out pulses, but instead of sending out one pulse and waiting and getting data back, we send out multiple pulses at a time and then get multiple pulses back and then we analyze all of the pulses. So we're analyzing like 88,000 pulses in which our data to say, hey, what is the scanner seeing? And with that, we can categorize objects as dirt, dust, a true object based on the intensity of the beam coming back. So with that, I'm going to show you a quick video. I like to do PowerPoint, video, just to break these up. This is going to be our robustness video, a corporate video.
Hello everybody. Welcome to our MicroScan3 performance check. In the following, some tests will show the benefits that characterize this new safety laser scanner. So let's get started. The MicroScan3 sets new benchmarks in terms of power-up time. It is ready to work after roughly 11 seconds. The display shows clearly which field is currently infringed: warning field 1, warning field 2, and the protective field. Let's start with our first resistance test. As you can see, the scanner doesn't get blinded by ambient light. Even next to a welding or grinding station, the MicroScan3 works reliably. Sparks don't affect its detection capability. The MicroScan3 continues working when it comes to contamination on the optics cover. Let's go one step further. Slight dirt deposits on the optics cover do not impair the view of the scanner. In order to simulate dust, let's trickle some white sugar through the protective field of the scanner. As you can see, the MicroScan3 continues working even when being faced with dust. And even in steamy environments, the MicroScan3 raises the bar. Let's test the reliability of the scanner in non-stationary applications. The MicroScan3 is extremely reliable when it comes to rotational movements or high vibration. Thanks for watching this video. Hopefully you now have a better insight into our new safety laser scanner MicroScan3 and its performance.
I always like to watch that video. It shows that, you know, we have made major improvements. If you've used any of the older scanners that don't have this HDDM technology, those issues will be exaggerated. I mean, you can, now that you know that they're out there, you'll see what the issues are. But we've been fighting those forever. The new laser scanner has greatly improved on those, I'll call them flaws, but they're inherent issues with using time-of-flight technology. So that's what we call robustness. So what is the HDDM? The HDDM technology that we keep talking about is just this. It's, we have more than 80,000 pulses per scan. A normal scanner, our competitor scanners, and our older S3000, S300s had 500 pulses. As the laser spins in the around the device, it would have 500 measurements, and you had to work with those 500 measurements. Now we have 80,000 pulses and 80,000 measurements to deal with, and so that gives us a lot more ability to filter out false trips. And that's the technology, just to make a point of how we can get these scanners rated for outdoor use. These are the robustness built into the indoor scanner is the same robustness that is for the outdoor scanner, except we were able to pass the tests for using it in outdoors. So that's how robust these things are. So we do actually have a scanner now that's rated for outdoor use. So what else do we have? So the other thing that we threw into the new scanner, everybody's talking about networks, everything's networkable. So we have, but yet you still want them to be easy. So we have standard scanners with a core I/O, we would call it. It's just an M12 5-pin. You give it power, and it gives you outputs based on your protective field and warning field. And you can step up to Ethernet IP. If you've got more than one scanner and you don't want to do all the wiring, back and forth, you just want to have an Ethernet cable. We've got Ethernet SIP safety. We're the only people in the world that have Ethernet SIP safety. So we can tie these things directly back to a Rockwell PLC, or we have our own Ethernet SIP safety controller ourselves. So if you need an inexpensive system and you want it over Ethernet SIP safety, a network everybody knows, we're the people that have it. If you're working with Siemens, we can do Profinet. So we are the only people in the world with a scanner that has all of the safe networks in them. The scanners also have the traditional, we've always had a configuration backup cloning module built into the scanners, so that easy replacement happens. If somebody would run into the laser scanner, you just pop the head off, put a new one on, and you download, or you don't even have to download, cycle power, and you're good to go. So this just reiterates, if you go from right to left, I/O. If you want just I/O and you say, hey, I don't want anything complicated, I don't know networks, we got the scanner for you. Very simple to program. If you want FE Pro, which is Ethernet SIP safety, and you want to go to, Russ, I want an inexpensive safety controller, but I know Ethernet, I want to go over Ethernet, you can either buy a complete system from us, or you could connect this to a Rockwell PLC, which is what we're showing over here. So you can connect to ours over Ethernet, you can connect to Rockwell's over Ethernet SIP safety, or you can connect to Siemens over Profinet. We're the only people in the world that has this type of versatility. The scanners have a lot of capabilities, 128 fields, and you can use multiple fields simultaneously. So you have 8 simultaneous fields. Why would you do that? Well, especially if you're using it over a network and you have a robot like we have over here, you would want those 8 simultaneous fields. It would be 8 different quadrants. You'd send that data through the FANUC robot or whoever's robot, saying, hey, somebody's in quadrant 1. The robot then can be programmed to do things in different areas. Now the person's in 2, and then the robot can react, and that's called cooperative robotics. And these scanners tie right into the robots. They tie into our controller, and we tie into the robots. We have complete kits using these scanners to go right to your robot. So this is just an example of 8 simultaneous fields. This guy walks in, he's in 1, 2, now he's in 3. The robot knows it can work in 7 and 8, but can't work in 6 because the guy's in 3, he's getting closer. So every quadrant this guy gets in, this robot adjusts where it needs to be or can be based on where the person is standing. This is an example of an AGV. You see you've got scans to the right and to the left and straight on. So this would be 3 simultaneous fields at the same time. One looking left, one looking right, one looking straight on. It's like when I got my backup camera in my car and it looks to the right and left, it says, there's somebody coming from the right, you better stop. So that's what this is doing. Super easy to configure and to understand. If I go up to a scanner, they go into sleep mode. A green check mark simply means it's good to go. Red means that it's infringed. The little arrow means I need to be reset. So it's very simple and very intuitive. So this is where we talk about a quorum Pro. A core has 4 simultaneous field sets and up to 8 monitoring cases. A Pro has 8 simultaneous field sets and 128 monitoring cases. So 128 is a lot of cases, and 8 simultaneous fields is a lot, but it is often needed in the AGV market and AGC market, automatic guided vehicles. Once Jim mentioned in his introduction that we have the 275-degree angle. So what that is we can scan all the way around the scanner, even behind the scanner. There's a small dead band in the back, whereas the scanner has to be recalibrated every time it spins around. So most scanners on the market have 180 or 190 degrees of angle. With the 275, it allows you to put the scanner on the side of a machine and be able to get that full 90-degree field of view, so you can go completely around that side of the machine. You get measurement data out of them, angular resolution. This angular resolution, that corresponds with the range. So we got 9 meters. We have to pulse the laser much more often in smaller slices in order to get out to 9 meters. So we have the longest range and the largest field of view of any scanner on the market. One of the things they did in the 9-meter scanner is they added a 60-millimeter resolution. The resolution is the guaranteed size of object that the scanner is going to detect. And normally it's 70 millimeters for an ankle, but because you're going out so far at 99 meters, they actually put in a 60-millimeter resolution as an option, because then you can lower your scanner and put it down where your ankle is a little skinnier. It's just one of the small things that they did to make the scanner a little bit more user-friendly. So this reiterating, we can tie right into a Rockwell, the PLC, a Rockwell PLC, a Siemens PLC, or a FlexiSoft safety PLC. Our FE Pro is Ethernet SIP safety. So you have Ethernet SIP safety, ProfiSafe, and Ethernet SIP safety on the Rockwell side. So when we say FE Pro, we mean Ethernet SIP safety. So now we're going to jump into the latest family. It's the miniature microscan. It's called the nanoScan. Now this is the smallest laser scanner in the world. It's also the laser scanner that is the lowest cost on the market right now, because it's made for these type of applications. It's made for AGCs, automatic guided carts. Automatic guided carts don't cost much. They're maybe $10,000. So you can't have a $3,000 scanner on a $10,000 cart. So we made this new scanner, just launched late last year. And it's small. It's got all the same technology as the MicroScan, all the robustness built in. The difference is it's smaller and it has a shorter range. So it's compact, it's reliable, it's got all the same tried and true technology, user-friendly programming. It comes with safe I/O. It does not have Ethernet SIP safety because this type of market doesn't use that. It has safe I/O, and it has Ethernet data, which they use for navigation and for localization. But it is really good for industrial applications. It's designed for the automatic guided cart market, but it's perfectly suitable for just a standard industrial application as well. And you get the benefit of the lower cost and the high robustness. To give you a feel, it's the size is about half the size of a, side by side. When I go live, we'll be able to see that. So they're highly reliable. They're just showing the robustness, which we saw in the video. Same robustness technology as in the nanoScan as in the MicroScan. On the right side here, they're trying to show measurement data. Measurement data is used for localization. So that would come out over the Ethernet port. It has the diagnostics built in, easy programming. It's the same software, same everything as the MicroScan. So the idea is if you don't need, it has a 3-meter range. So if you need 3 meters or less, this is the scanner. In safety range, this is a scanner probably to go to. If you need 3 meters plus, the MicroScan is the scanner to go to. Some of the nice things about it, yeah, SICK has gone, we've heard your voices, the voice of the customers. They were tired of proprietary cables and selling us product and then having to get super special cables. So we went on all of the new products that we're promoting, standard cable, standard micro USB cable, standard IO cables. Now, Sometimes when you get to 17 pins, it's not quite as standard as you'd like, but it's all you can do when you have 17 pins. But they're not crazy expensive anymore. Standard Ethernet and Ethernet SIP safety is an open protocol, or it's a Rockwell protocol, but Omron also uses it, SICK uses it. It's one of the most popular protocols out there. And of course, we build in the system plug so that you always have cloning built in. This is what an architecture would look like. You'd have your scanners, showing it going to a vehicle control. You'd have your safe I/O, and then your non-safe Ethernet goes off into a navigation system. We're not talking much about AGVs. This would just be if I wanted to take my non-safe Ethernet into a non-safe Ethernet card and then go back to my PLC. So you can use the Ethernet on it for doing localization and things like that, programming and things like that. But most of the time it's used for the AGV software, for the navigation software. So like the MicroScan, same thing. It's got multiple individual fields, 128 fields. One thing that we have that's unique to us is contour as reference. So if you have say a robot cell and you've got your laser scanner programmed inside, and you can actually take the door of the robot cell if it happens to be closed or something stationary, and if the door opens, boom, it'll set off the outputs and say, hey, somebody opened the door, because the contour of the door was your reference. So it's got 375 3 meter range max. That's the safety range. 10 meters of warning. 275 degrees. That 275 is again important because it can scan behind itself, so you can get on a corner of a machine and get both sides. It's still performance level 3 and performance level D, and it's comparable to the MicroScan. It's just showing the different variants. You can get it in an 8-pin, 17 cables with open leads, different formats. The core, this is the difference between a core and a pro. Number of fields, 8 in a core. This would be the one that most factory automation people would use. You'd have 8 fields, 4 simultaneous fields, 2 monitoring cases, 1 pairable SSDs. Dynamic case switching you wouldn't have, because dynamic would be over the using encoders. You'd have to give it an input to change cases, and you can have Ethernet or not have it on this. And same thing on the Pro. It's just got more of everything. This is the system plug. They look different than the ones in the past. So you can get different variants. If you want just the basic I/O, 8-pin, A-coded standard cable, boom, that would probably be your most likely cable configuration, and that is your system plug and pigtail for your cable to go back to your home run, back to your cabinet. So once again, easy use, certified for vertical applications as well, super small and space saving. So we'll reiterate some of the technologies. I put in my product spotlights. We have 25 years of technology. The key things to take away on the MicroScan is it's got the longest range on the market. It's got 275-degree scan angle. That's the best on the market. It has been tested and verified in outdoor applications. So we are safety rated for outdoor applications. It's called the outdoor scan, but it's basically the same scanner. Built for harsh duty applications with the safe HDDM. You've got your safe networks, the only people with safe Ethernet SIP safety, but you can also get just a basic core I/O unit. Very easy to program, small. You've got your super fast 40 millisecond response time. In your Ethernet, you can connect it in all the different topologies. It's got a managed switch built in. So this is a really nice scanner. Up here is where they're showing why the 275 degrees is important. You want to set the scanner on the corner and you want to catch both sides of this machine. You can cover it with one scanner, where in many cases you'd need two of them. Then we talked about the nanoScan. What were the highlights with that? Mainly, it's the size. Size and price are the biggest thing that highlight the nanoScan. Super small, easy to work with, and low price. It does also have dual OSSD outputs, so you could guard two machines with it, one to the left, one to the right, and have two separate OSSD outputs. That's another nice thing. These are fast selling right now, just because the AGV and AGC market is going crazy. So now we'll open it up for a quick live here, show you some product. Oh, did I stop sharing my screen? Okay. Actually, let's do that. Okay, so this is the MicroScan. This is the Core I/O, so you can see it's just a standard M12 5-pin. And this is the nanoScan side by side. I happen to have this one with, it's got Ethernet coming out, and then I just have standard a 2-meter cable coming out for your I/O. So very simple. Get cables out of the way. Right here, we're showing, this is Ethernet SIP safety. All I'm running is power to the scanner, and then out of the scanner, I come into my Ethernet module. The second cable allows me to program the scanner and our CPU and our safety controller. And that is super nice. Everything's in one suite. So you can, and I'm just connected to the scanner, and I can go in through the network and program everything all in one suite. I don't have to go back and forth, Rockwell software, then go back to 6 software, and learn both of them. It's all in Safety Designer. Really a nice system. And being that we're the only people in the world that have this, we're still very competitive on it, and it saves in wiring. If you were to wire up, say, 2, 3, 4 scanners, you would just take Ethernet out to the Ethernet module. On the second one, I would just daisy chain it to the next scanner. It's got a managed switch built in. It'd be a line topology, and I can program all of them and the safety controller in one. So this is the MicroScan nanoScan. This is the little nanoScan just powered up. And then this would be, most of you who have sat in on my video, this is my robot. Can you see it? Probably barely. And so this is a system. This is a Core I/O system. It's a MicroScan connected to a robot, and I've got my safety control. So this is all a kit from SICK, made so that if my people enter the area, my robot slows down, and if they get closer, it stops. And we have custom function blocks built in so that the robot keeps running while the person is in the warning field, but it slows down and it shrinks the protective field. So that allows extra production because the person can walk into the second protection zone because we've sent the robot a signal saying slow down, and the robot said, I'm slowed down. And we say, okay, now we can get close enough. So these are super intelligent devices, and all the programs are set for you. So this would be considered a system that we could sell you. Then when the person walks up to the robot, does its thing, we have a custom function block, which is required by the RIA to allow for the scanner to take off and keep running without pressing a reset. The last thing I wanted to show you was one of our cool tools. It's not so, not too exciting, but so you've got your laser scanner, and I call this, how do I know where my laser is hitting? So this is telling me where that laser is hitting. Should be able to see red. And then down here is where this one's sitting. So right now I've got a scanner here. It's going to be at about 300 millimeters. This scanner here is at about 10 centimeters off the ground. So it's really nice because you can see where your laser beam is hitting. If your scanner happens to be on a little bit of an angle, which I think this one is up a little bit, you can find that. And at 9 meters away, it's a really nice tool to be able to see your lasers. So with that, let's open it up for questions.
Yep, yeah, feel free. I'm going to click unmute here. So feel free, if you see yourself muted, unmute yourself and ask any questions. A couple of things I wanted to point out.
Yeah.
Number one is the 80,000 scans per measurement that Russ mentioned, referring to the HDDM technology. I can personally attest to that helping us out in a variety of different applications, specifically punch press applications where there's oil, grease, everything flying through the air. Number two, we had a customer who actually was using these scanners around a water jet cutting cell, and water was dropping down through the scan zone. And with that HDDM technology, it could actually detect the water, but you could set it up to ignore it as long as it wasn't a certain size blob, where other scanners, if that was happening, even the older 6 scanners had trouble with that kind of application. That was one thing. The other thing you saw, we had the safety controllers as well. For those of you on this call, I mean, Russ mentioned the nanoScan for the AGC or AGV market. We also have, so that nanoScan had the Ethernet data output. So that can tell you what's going on around the scanner and around the vehicle. We do also have non-safety versions of these scanners as well. If you want some more information about those, there's versions called the LMS, MRS, and the TIM, which are the non-safety versions. So those are meant to do area monitoring, not necessarily to protect from human injury. So in those scanners, we have some even lower cost options, and we have versions that can output the data via serial, via USB and Ethernet as well. So if you have some kind of application for that, definitely let us know, because there's a whole different market for that as well. And last thing is, you saw the safety controller. So with the SIP safety or the Ethernet safety versions of these scanners, we do, we mentioned obviously Rockwell, everybody knows Rockwell's got the safety controls, they have the SIP safety, but SICK has that as well. So we can interface with pretty much anybody who has SIP safety. So that goes back to Rockwell's controllers, SICK's controllers, and then also quite a bit of different robots. I think Fanuc is who kind of came out with that SIP safety standard. So their robots and other people's robots as well have that. So that makes configuring scanners to guard robot cells and robot applications very simple and easy. So
yeah, we have complete kits for that. It's the main ones for with Ethernet SIP safety, which is the way to go, is Fanuc, Yaskawa, KUKA, all have Ethernet SIP safety on board, and we have the complete system to tie into theirs completely, you know, and with instructions and everything. So yeah, if you've got robots, you really want to look at our SBOT systems, because we do the programming for you, which is really kind of nice.
Yep.
Russ, this is Dan. I got a question for you. Basically, what we're seeing on your screen right now, this is kind of a live image of the scanner as it's sitting on your desk there, right?
Yes.
Okay, so this output, is that output, can you send this information like serially or by Ethernet?
Yes, absolutely.
Okay.
As a matter of fact, it's done all the time like that. And so if I were to go into, I think under data recorder, I think is where it's at. So right now, it's a current live view. Yeah, it's the same live view. You can get this data out, and we even have, it's called a Visio tool. It's a software that you can put on your HMI, or you can put on your computer that just gives you this. It gives you this, and then it can also give you things like the event history, which is when I look at this is kind of cool. It says, this is a chart that tells me, you can get this on the visualization tool, which is free. And it says, hey, I've had some infringements on my scanner. And this is just the number of scans. So I had a bunch of them that were one, because I was dropping a business card down below the scanner, just going like this, trying to fool it. Those would be the ones. And then it says, hey, I got a bunch of them that were two. So this would give me some feedback that tells me, hey, how many, when did I have, trips? How many scans were they? I think it even categorizes them as which cutoff path. Somewhere in here, it says it's an object, but not a person, and things like that. So it's kind of cool. And that all can be outputted, if you have Ethernet. It all can come out and you can watch it over your HMI or over your computer, even over like a network of some sort.
Gotcha. And also just to mention, we're looking at a lot of horizontal applications, but there's no need to limit this to just horizontal applications. You can mount this on an angle. You can mount it vertically looking down to essentially, let's say, monitor a door opening, if you will.
Absolutely, yeah. Yeah, it's certified for vertical applications as well. Yep. And in that case, most of the time people use a feature called contour as reference. If you mounted it vertically like a light curtain, you would set the floor as your contour as reference. So it would say, look, I got to see the floor. And they do that so that you can't override it. Sometimes people take a scanner, flip it up in the air and go, oh, now it's defeatable. Or you can mount it, on an angle and looking at a door, like I mentioned, in a robot cell or some sort, or even horizontal, looking at and have a complete field, and a second field is just looking at the door. When the door opens, boom, that's something you have to shut down.
Yeah, that's a good point. I mean, typically, you would have to or want to use that contour as reference, because if you have a big building and you're pointing it down towards the floor and somebody just faces it up, now it's looking out into nowhere and it's going to always be okay. But that contour as reference will say, hey, I don't see what I'm supposed to see, and that'll trip it off. Another thing I want to mention for those who are thinking about potentially using the data output from the scanner. Russ, I don't know if you can zoom out just a little in your image there, because
do it here.
One thing, I mean, they have the visualization tool, which is really nice because it can kind of take all that data and put it in something like this. But imagine a scanner, and let's just say the scanner can measure every quarter of a degree. So this blue line in this image is technically a bunch of dots, and every quarter of a degree it's measuring, or it's telling you where that dot is or where it's seeing the light reflect. So it's a lot of data coming back. I mean, I can't remember exactly the speed of how fast it spins around, but if it's 80 or 100 milliseconds.
40 milliseconds.
Yeah, you're going to get that much data in that short of a period of time over and over and over again. So you have to have some way to crunch that data. A lot of times what I've seen is people will just use it to monitor certain spots or certain areas at a certain time. So you're just monitoring a few of the different degrees of the different areas that the scanner is measuring. So that's a good way to do it. But yeah, we've even had customers that use this data to even map out rooms and map out areas. So there's a lot you can do with it, but you have to know that there's a lot of data coming back. Right now, you can see in that image, that dotted line that is kind of coming in on the corners, that's the maximum safety zone of that scanner. So you could draw your safety field anywhere inside that zone, and it's going to be safety rated. What is it? SIL 3, performance level D.
There we go.
So yeah, there is the capability of doing what they call a warning zone out even further than that. So I think the MicroScan can go 40 meters and the nanoScan can go 10 meters. And you can use that warning zone as a non-safety output. So outside of there, up to 10 meters long, you can monitor things too. Typically, they're used for just telling people when they're getting close to the safety field or things like that. So just know that too, because that's kind of a good tool to potentially use if it helps.
And you can use this. Correct me if I'm not correct, but you could use this both in a safety type scenario, but it doesn't have to be a safety type scenario.
No, I have people that use it as a in other applications where they just want to detect, you know, boards or whatever, because it's an easy product to use, or for yeah, just about anything. It's just giving you an output when somebody's in the area. And then if you wanted to go, the warning zone is just a PNP output that says, hey, there's somebody in the warning area, set off a buzzer or things like that. So yeah, it can be used in non-safe applications as well.
What's the commissioning process like for, like, if you had a semi-mobile application where you had to move the sensor or a set of sensors to one location and say, hey, make sure this area is safe, and then walk away?
Yeah, so, so if I walk through this just step by step, give it a name, tell which language, upside down, straight up and down, monitoring plane. What am I trying to detect? Legs, horizontal. You know, so far it's just clicking boxes. Then when you get to fields, this would be your main you know, where you draw out your different fields. I'm blocking out some of these so I can just see one or two. So my slow zone. So in this case, I've got 3 zones. If you had, like, say you had 2 or 3 areas that you normally go to, the easiest way might be to say, have 3 different field sets. Like I have, well, in this case, I've got 1, 2, 3, 4 of them. You know, they happen to be called full speed, fast, medium, and slow. So you could, if you move the machine, you could say, hey, I'm at the second machine number 2. Boom, you go to field set number 2. That would be, or monitor case number 2. So right in here, you would say, based on an input, 1, you know, these different inputs would tell you which, you know, set of fields you're going to be using. In this one, I happen to be hooked up to an AGC one, which it is using the using speed as a reference, just because that's the type of thing that you would do for that. But in most cases, you just say, send me a signal, I'm going to machine number 2. Does that answer the question?
No, I was more getting at, like, an automated process for detecting, like, if there's a wall nearby within what would normally be a detection area, ignoring that wall, but knowing that that was like the limit of the detection area.
Oh, so then you would be going into your fields here and like drawing this field and saying this is the wall over here, that blue area, and redrawing it each time.
But is there an automated way of saying, look, this is the room by which you should be looking into, or this is the field that you should be determining is safe?
The only way you could be doing that would be, I believe I can do that as a contours reference. So I could you'd set up numerous contours as reference, and you're saying, hey, if I see this wall, I know I'm in this room. Is that what you're saying?
No, I'm saying, say you have like a mobile device, you move it
Yeah.
into a room and you say, I want you to make sure that this room is safe from intrusion. And
Okay.
then, and so you, ideally the user just hits a button and then walks away. And then there's a commissioning process for determining that there's a safety area in the room. And then it's working from then on.
Yeah, so it's not quite that simple with safety because we do have what we call like a teach-in process. Which one it is here? This one. So you'd have to log into the actual software, do a teach-in of the room, scan the whole room, and then download and verify the program.
Russ,
Because
what
it's
if it
safe.
wasn't? What if you're not looking at it necessarily from the safety? Because when you and I hear the word safety, that's a completely different scenario than
Right.
I think what Devlin is maybe getting at. This is more like, I think, if I'm understanding what Devlin's looking at, it's you put this system in a room and you want to map the room. You want to look and kind of get the
No, I
contours of the room.
I do want to use it as safety in the room.
Okay. Oh, okay. Okay. But then, so we want to map the room. We don't necessarily know what the room looks like. We want to
Right.
map it, and then we want to set it up so that if anything changes our mapping, if somebody walks in the room and changes that contour that we just created, we want to be able to stop our operation. Is that
Yeah.
good summary, Devlin?
Yes.
Yeah, so the easiest way for that to do would be set it in the room, do a teach-in process, and that'll go out and scan the whole room. And then you do a download and verify. So it's not like a one button. It's not quite as that simple, just because in safety, you have to verify it. So you have to hit the button, teach the area, and it'll automatically see the whole room. It'll shrink the field set down automatically by 63 millimeters so that it's not getting false trips off of the walls and things like that. So it does all that automatically, but you still have to download it and then say, yep, this is what I want, and verify, and you're good to go.
Can that process be automated?
No.
Yeah, I don't think
on the software. It's done on the safety designer software.
right, because I think that's actually part of the safety standard is that somebody, in order to draw your safety field, you need to actually, a person has to manually click and say, yes, this is verified, now send it to the controller. So that's why you would have to open up the software to do that.
Yeah.
So, I mean, pretty much all of the safety scanners that SICK has ever had have that same, once you're going to draw that field in, you draw it in, whether you're teaching it or drawing it by hand. I mean, it's technically an automated process in the teaching of it, but you still have to bring the software up. And then once you do that, then you still have to download and verify. So that's a couple extra there. And if I'm not mistaken, I believe that's specifically written into the safety standard that on controllers and on scanners, that any changes to programs have to be manually entered and verified. So that would be kind of difficult to do. I mean, so the software is downloadable, free. There's no licensing, charges for it. It would have to be, on the machine, I guess, or somehow connected to the scanner, so that somebody in that room could do that. I mean, it doesn't take very long, but they'd have to manually do it instead of having it go click teach and leave the room. That probably wouldn't be as easy as if it was a non-safety scanner like we talked about. Yeah, you could have some kind of controller that's monitoring the field and doing that with just an input. But safety-wise is when you run into that verification issue.
Yeah.
Okay.
Yeah, unfortunately.
Can you show some examples of dealing with crosstalk on those sensors?
Yeah.
So you needed two of them opposed?
Yeah. I've got, let's see what I've got here. Yeah, you know what? I've got a MicroScan. I can put it on the same plane as the, be in the same area. I can see where I'm at.
Can you guys see Russ in the video?
Oh, I can make it bigger. Hold on, let me stop sharing my
It's small
screen.
video, but
Yeah, so I mean, if I look here, I should be able to tell when my scanners are at the exact same height. It should be right now. Trying to see if that one will give me any trouble. I got to be outside the. I'm within the range on this one, so we go behind it.
yeah, with so I can kind of tell you from example from experience in the older series scanners, like Russ mentioned, the PLS and the S3000, you actually did have to mount them either on an angle to each other or plus or minus. I think I remember, depends on how far away they were from each other, but I had an application where it was a big long stamping press and there were actually 4 scanners, and we did have an issue because they were mounted at the same height originally, and every now and then they would trip because of what they call dazzling each other. But that I to be honest, I haven't seen any cases where I've seen that kind of error with the MicroScan or something later than that.
No, you won't.
HDDM technology and all of the light and all of the receivers that they're taking measurements on, they almost have a built-in what do you call it on the light curtains?
Yeah, pulses. They've got.
They're pulsing the light, but since they have so much data coming in, they can pretty easily identify their own signs versus the other scanners.
They encode their own pulses.
Yeah.
Correct.
Try and see something. I thought there was an area on the MicroScan. If you really had, were concerned about it, like you had, bazillion, 6, 8, 10 of these all on the same plane, and you thought you were having an issue. There was an area on the MicroScan, I think they even took it off of here, where you could, offset the frequency. I think they took that out.
Can you artificially constrain the angle? Can you tell it to only go 180 degrees?
No, well, the laser beam is spinning around the scanner, so even though you're only looking 180, you can say only look 180 degrees, but your laser beam is still spinning the full 365 degrees around.
Okay.
That makes sense. Yeah.
Do you have a maximum magnetic field in which they can operate?
I do not know that magnetic field in terms of like in a foundry where you have the big magnets, or
Sure, a foundry or MR suite.
I would have to ask that. I haven't heard that one before.
Yeah, we can get you an answer on that. I haven't ever seen that or heard or been asked that before.
Yeah, that one I don't know.
There is a rotating motor on the inside of them, so I would imagine there's probably some kind of specification for that.
Right, but it would likely saturate or something along with any other magnetic parts in there.
Right.
But to what extent, of what field does it saturate? That's the question.
Okay. All right. Yeah, we can get that. Just writing that down so we can remember. We are also recording this webinar, so we'll send out the link. So if you want to review or send to anybody else in your company, then that would be that'd be possible. We'll send it out to everybody who's on here and registered. All right. Yeah. I mean, if anybody has any other questions, feel free to reach them out. I mean, we've been in operation since the pandemic came down. Russ is up in Wisconsin right now. All control. I'm in our Elgin office in Elgin, Illinois. But yeah, we're willing to come out and show you things in person if that works for you guys. And then yeah, we can get these answers back for you and hopefully even potentially demo some actual product.
Yeah, we have a complete process for coming to visit you. We have a sanitation process. We have masks. We have PPE. Everything is sanitized, and we check our temperature every day. And what I've been seeing is when I do go out, companies have you fill out a form that says, "Have you had a fever in the last week?" or "Have you?" We're all ready for all of that. So staying healthy and ready to come visit and show you if you're comfortable. We're open for business. So.
All right. So any other questions, feel free to reach them out. Otherwise, get in touch with us after this is done. And yeah, we'll be happy to help you. One thing I didn't mention that I wanted to is, SICK and All Control also do work together on safety services. So back to solving or preparing an entire application from risk assessment all the way up to install and verification. So if there's questions you guys have about machinery, how do you safeguard certain things? What should I look at on my machine that could be a potential risk? We can help that as well. SICK has a full services group that actually will come out and do a really nice setup and reports on every level, from risk assessment to engineering design to install and then verification. So that's a big deal as well. So good. All right. Well, with that, it's right at 11 o'clock. So we lasted an hour. Hopefully you guys got something out of this. And if there's more you want to discuss or you want to see some product in person, let us know. And thank you everybody for attending. We did mention we will do a drawing at the end of June and for I think Apple AirPods that we were going to give away. So we'll let you know who wins those, and then we'll and make sure you look out for potentially more of these coming in the future.
Perfect.
So
Thank you
for attending. I'm going to go ahead and close it.
Thanks, guys.
Yep. If there's more, let us know.
Thanks, Russ.
You're welcome.
Russ, I believe you're the host now, or no, I am. So I'm going to go ahead and shut this thing off.